All right, so what we're going to do now is we are sampling groundwater wells, which we drilled up here in Gordon Gulch last spring. What we're looking for here is some similar things we're looking to with the surface water. We do this on a weekly basis, like we do the surface water sampling. We're getting a chemical and isotopic signature of the groundwater in the area, as well as we take a depth to water measurement every time we're here as well to determine how far down it is to the water table, which is the water that is, underneath our feet right here in the bottom of the gulch. So you can't really see it very well, but off to my right over here we have the headwaters of Gordon Creek right here. So this is where we have water coming up out of the ground and goes into a little creek over there. And talk a little bit more about the water table. The water table rises and falls throughout the course of the season. The highest point of the year is going to be when it's receiving input from snow melt. So in the springtime, when the snowpack in this area starts to melt and go down into the ground, the water levels that we measure in these wells are going to come up as the groundwater is recharged by that snow melt. Something else about the water table, it generally follows the surrounding topography. So we would expect, rather similar depths. We have 4 wells relatively close together here, and we would expect to get, pretty similar measurements of depth to water. We do have wells up on the south-facing and north-facing slopes as well. Those are deeper wells. They're up higher, so the depth to the water table is deeper. But generally, if you have a valley like this, as we do here, the water is going to be closest to the surface down in the bottom. It kind of follows the topography like this, but as you get up higher, you'll also see generally a greater depth to water there. So this little guy right here is called a conductivity meter. It's different than our conductivity probe, which gives us an actual number of the conductivity of the water. This one is just used for measuring a depth down to water, and what it does is it has these little metal ends on it, and when these touch water and complete the connection between the two, it makes a little beep like that, and we can tell how far it is down to the water. This guy we stick on the top of the casing in the exact same spot each time, and this makes sure that when we have different people out here doing the same job, that they're going to measure in the exact same way every time. So we clip this guy on I have Sharpie marks on there so we can measure in the exact same spot every time. And we just drop this guy down in there until it beeps and read the marks off the tape. You can see there's a little V-notch groove in this guy, and that's where that ensures we get a very accurate measurement each time we do this. So you can read down on the tape, and we have a measurement of 335 centimeters depth to water here. So we have another more accurate way of measuring our depth to water as well. This little silver thing in my hand is called a pressure transducer, and we lower this down into the well on a stainless steel cable, and it sits in the same position in the well, and it measures how much pressure is exerted on a small membrane in the bottom of it, so we can keep track of the change in the water table more accurately than we can with our manual measurements. The manual measurements that I showed you before, we only do those once a week, whereas this records on the 10-minute time step, similar to most of the other instrumentation that we have out in the field. We have a special locking well cap to keep anybody from getting in there and messing with our wells.